The focus of this course will be on enterprise software engineering, which is how we go about engineering and re-engineering large-scale software systems, large-scale software services, and large-scale software organizations that support the operation and the evolution of an enterprise, which is itself large-scale. Because these software systems, software organizations, software services, as well as the enterprises in which they operate are complex, we will approach um, this study through frameworks, which are essentially systematic techniques for defining, understanding, and constructing these enterprise scale software systems. So, what are frameworks? So, frameworks are essentially systematic techniques for understanding or defining or constructing things. Um, so more formally, they are representations. Okay, so drawings are representations, models are representations. They're also principles, rules, for example, that must be followed for understanding whatever aspect the framework is supposed to address. And they're also techniques. So there are also tactics or strategies or algorithms or methodologies used to both illustrate as well as guide practice. So once you've represented a system using a framework, it can also serve as the documentation for that system. It can also serve as a way for designing a system or for modifying a system once it's been built. Hope that makes sense. And the final thing about a framework is there should also be capabilities within the framework for measuring performance. So once the system has been built and it's actually being used, there should be some systematic technique for understanding how well it's operating, and if it fails in its operation in some manner, figuring out where it has failed, how it has failed, things like that. So frameworks are techniques to both define and frame the problem, as well as to define the solution, as well as to evaluate the solution to this problem. So you might think frameworks are something new, but they really aren't. You've seen frameworks before, you use them all the time. If you've taken a physics class, the equations of motion are essentially a framework. If you've taken a business class, then a balance sheet or the concept behind a balance sheet is also another framework. In the latter case, in the former case, the equations of motion help you understand and predict the motion of physical bodies. In the latter case, a company balance sheet helps you understand, perhaps predict the performance or the status of a company. Now, as I said when I went over the syllabus with you, we said that this would be an active learning class. The other aspect of this class is that we will try to measure your learning as you go as well. Partly because this is a requirement of the National Science Foundation grant that supports this curriculum effort, the software engineering curriculum effort, but also because we are very interested in seeing how you learn using this new approach that we are incorporating in this class, around lectures that are listened to offline, and then workshops that are done in class as opposed to the other way around. So we hope to measure learning at 4 levels. So at the level of reactions, which is level 1, that would be measured by basically how engaged you are in class and how interactive you are with the instructor and with each other. Also, how well you rate the class in the student evaluations of instruction. Level 2, we are interested in measuring your recall. So with the quizzes and in the final, we will measure how well you remember what was presented in the lecture, in the reading material, and so on. So there is an element of memorization and recall in this class. There's no getting away from that. But then we also want to measure your ability to apply the concepts that we've taught in class. So, and we will measure that by taking a look at how you do in your projects, giving you feedback on your projects, things like that. And we will continue this measurement if you should take a capstone course following the software engineering course, in particular CSE 758, which is the software engineering capstone. but also CSE 762, which is the web services capstone, will try to see how well you incorporate principles from this class as you do those real projects. And in certain of the capstones, there will be students who would not have taken 757, but would be taking, say, 762 and so on directly without, this course. So we will try to see how much better or worse or differently folks who have taken 757 do in those capstone classes when compared with students who have not taken 757. Okay, and then the last level of measurement is what is known as transfer. So transfer is, let's say you've learned a bunch of principles or techniques in a class. How well you've understood them to the extent that you're now then able to customize these techniques or apply them in ways that weren't anticipated when you were taught these techniques. Whether you're able to improve on these techniques, things like that. And also, are you able to use these techniques to effect organizational change? So you're working for a company that, say, doesn't do agile development. You are able to bring in some of the techniques we use in this class to help them do agile development, but not just to do agile development, but actually create software that is better, that sells better, that performs better, that is more usable, things like that. Each of these applications being targeted towards a different stakeholder. So a stakeholder is somebody who might be an employee, might be a customer, could be a manager, basically the kinds of people who interact with the company. So coming back to the enterprise system, there are typically applications or groups of applications that are targeted towards specific stakeholders, and there are many stakeholders, so there are many, many applications. Ultimately, all these applications serve some aspect of the company. So there's really a connection or a relationship among these applications as well. This relationship might typically be of two kinds. The first kind is around shared data. So one application, such as the sales and delivery application, will have a notion of a customer. And then the inventory and supply chain application will also have a notion of a customer. At the sales and delivery side, the customer will be someone who buys something. At the inventory and supply applications, the customer will be somebody who receives something, who sent something, a product or something like that. Okay, so that's what we mean by shared data, and certainly all the applications will have some notion of um, the money that is earned, things like that. So this central database that we show in the middle is a conceptually centralized database. I didn't mean to imply with this application that there was an actual central database that all these applications worked off. What I'm really trying to say here is that there is this notion of enterprise data that's shared by all these applications. Okay. The second thing that these applications will share are processes. So there will be processes that begin at one application, go through other applications, and sort of end at another application. And once again, let's take the example of somebody buying something from this company. Okay, so that process of buying something, so it's known as the order to cash process. Okay, so you place an order, and ultimately you pay your cash, and then you receive the product. All right. Would begin at the sales applications, right? Would begin at a website where you would buy the thing, and then and then you'd make the purchase there. There might be an inventory management application that is told that this item has been bought and inventory should be reduced by a certain amount. Um, and then there would be a shipping or a supply chain application that would then ship that product. So all these three applications are participating in one process. Okay, so keep this in mind that these different applications share or conceptually share data, and they also conceptually take part in common processes. All right. And then the last thing is that these different applications are targeted towards or geared towards multiple stakeholders. So there's not just one kind of business user. There's multiple kinds of business users. So now this diagram shows one of those applications, a prototypical application within that set of applications that make up the enterprise system. Okay, um, um, so typically this application will be architected as multiple layers. So the topmost layer will be a presentation layer. Here's where the user interacts with this with the application. Um, is able to provide input, is able to view output from the application. That's known as the presentation layer. The layer underneath that is usually called the business layer or the business logic layer. That's where the business operation actually takes place. Okay, so once again, think of an e-commerce application like Amazon. The web page is the presentation layer, and then when you click on buy, on buy the product, the business logic layer is the one that executes the transaction of buying. All right. Now, in order to execute that transaction of buying, the business logic layer has to call a bunch of services, and a typical service it will call is a database service. Okay, so in order to update something in inventory, or either add or delete, or add dollars to an account, or if the transaction happens to be the modification of an item, then the making the change to that item, something like that. But there are other services that this business layer might call as well. So there might be a remote system, for example, the warehouse system, which has to be told to ship a product, in which case it's going to call the service of the warehouse system. So keep in mind that this business logic layer will then turn around and call multiple services: a database service, a remote warehouse service, a remote credit card service, whatever it might be. And these services um, are implemented in what is known as the service layer. Now, these services will call um, functions, if you will, in the entities that provide those services. So there might be a database, um, there might be a web server that implements these web server services. There might be what is known as a message broker that sends these messages out. Those would make up the final or fourth layer of the enterprise system. Now these applications, the